Hello and welcome to T2 Day 8 of Honors Precalculus. Today we're going to add and subtract angle values inside trig functions and see what happens. Let's take a look at this statement right here. Does cosine of pi over 2 minus pi over 3 equal cosine of pi over 2 minus cosine of pi over 3? Can you distribute like that? Well, let's take a look. On the right hand side, cosine of pi over 2, you need to remember, is 0. It's the adjacent side over the hypotenuse. And then cosine of pi over 6, that's 60 degrees. That's going to be 1/2. So this comes out to be negative 1/2 on this side right here. So on this side, it is negative 1/2. Now, if we do the math on the left-hand side, you would want to simplify this fraction first. So if we simplify that fraction first, that's pi over 2 minus pi over 3. We're going to keep this separate for now. Need a common denominator, so multiply by 3 over 3 and 2 over 2, so you get 3 pi over 6 minus 2 pi over 6, and this is equal to pi over 6. So we're actually figuring out what is the cosine of pi over 6. Cosine of pi over 6 is root 3 over 2. These two things are not equal, so the left-hand side here is equal to root 3 over 2, and the right-hand side is equal to negative 1/2. So in this case, it's not true. So you can't do this. So the thing you think you might be able to, you can't. So then the question becomes, what is the formula for cosine of an angle A minus an angle B? Now, if you draw out a really cool diagram on a unit circle, and you draw out a general angle A right here, and a general angle B right there, so you have your B and you have your A, you can use some similar triangles and the distance formula, and what you end up with is this. Cosine of alpha minus beta, so cosine of A minus B, is equal to cosine A cosine B plus sine A sine B. This is something you have to memorize. You have to memorize this. And if you want to know where it comes from, you can go through this work that's on the page right here in your notes, but please, you have to memorize this. This tells us that cosine alpha minus B, so A, I'm calling it alpha, A minus B is equal to this right here, cosine A cosine B plus sine A sine B. You have to memorize that. So how do you apply it? Well, I could ask you what cosine of 15 is now, and that's not something that's on the nice regular unit circle, but we know that 15 is equal to 45 minus 30, and those are two trig values we do know a lot about, two angles that we know trig values of. So what you can do is you can say cosine of 15 degrees is equal to cosine of 45 degrees minus 15, 45 minus 30, 30, like this. And then you can use the formula above here. So it's cosine A cosine B, so it's going to be cosine 45 degrees cosine 30 degrees multiplied together plus sine of 45 degrees sine of 30 degrees. Now this is bigger, but we know all of these values. We know all of these values. So if you fill them in, you end up with this statement, and then you can simplify it even further. This is root 6 over 4 plus root 2 over 4. So this is going to be root 6 plus root 2 all over 4. You can't simplify that. Leave it just like this. So this is the exact answer using the formula that you were given. Now we're going to add in some more identities that you have to know. So you have A, B, C, D, and E. These are super, super important. It's kind of cool. Take the cosine of the negative of an angle. That's the cosine of the angle. And sine of negative of the angle is the opposite of sine of the angle. So these go on. You need to know all of these right here. These are super important. Why are they important? Well, what you can do here is then you could say, well, what is cosine of A plus B? Well, that's the same thing as writing cosine of A plus minus B, like this, just breaking it up. And we know from above, from our formula right up here, the one you had to memorize, it's cosine, cosine, sine, sine. This is equal to cosine of A cosine of negative B plus sine of A sine of negative B. We're just using the rule that we learned at the beginning. But then we know that cosine of negative theta is equal to cosine. So basically what that means is cosine A right here, this right here is going to be the same thing as cosine of B. And then this is still sine of A, and then this right here turns into negative sine of B, like this. So what that turns into is cosine A cosine B minus, because there's this one minus sign right here, sine of A, sine of B. So this is another identity you have to memorize. Now, there's other ones too. You can do the same type of work for sine of A plus B and sine of A minus B. You can do the same type of work, and you end up with these other identities right here. So you have the sine of the sum of two and the sine of the difference of two. Same type of work. You can look through this and practice it, but you're going to have to memorize these things. And yes, it is a lot to memorize, but the key ones to memorize really are one with sine and one with cosine. So for example, you could memorize this one and then derive the other two. There are similar rules for tangent, and these we're not going to derive, we're just going to list out. You need to know that they exist. So here are the ones for tangent. You just need to know that they exist. Some creative algebra and using some basic trig identities. So how do you use these to cool effect? Well, we can now find the exact values here, because in case this one, this is 60 plus 45. We're looking to break it into pieces that we know the exact trig values of. So this means that sine of 105 is going to be equal to sine of 60 plus 45. And above, what you can do is use the rule here from above, one of the identities, and that tells us that this is going to be, this is sine of, you're going to use sine of A plus B from above. There's an identity above. And if you use that, you can just write out, you break it into pieces that you know the trig values for. So sine of 60 degrees, you need to know, is root 3 over 2. Cosine of 45 is root 2 over 2. Cosine of 60 is 1/2. And sine of 45 is root 2 over 2. And you simplify this, you get root 6 over 4 plus root 2 over 4. Hey, pretty similar, huh? Root 6 plus root 2 over 4. So now let's go to radians with cosine of pi over 12. What do we do with that? Well, if it helps you, pi over 12 is half of pi over 6, so that's 15 degrees. So we can think of it that way if you want, if that's easier. So another way to write 15 is 45 minus 30. So in this case, what we're going to have is cosine of 45 degrees minus 30 degrees. And this, using the rule above, you're going to end up with this, because you're using cosine A minus B. So this one is cosine of A minus B. You can use it above. So now these are all trig values you know. If you fill in the trig values, you get these radicals that you've seen before. So root 6 over 4 plus root 2 over 4. It just happens that we end up with this wonderful statement again. Yay, very cool. So 5 pi over 12, you can do that out, where pi over 6 is 30, so pi over 12 is 15. So this is 5 times 15. This is the same thing as sine of 75 degrees. It's easier to see the fractions that way. So this is going to be equal to sine of 45 plus 30. So using the identity above, you're using sine of alpha A plus B. You can use the identity above. You end up with this statement, and you know the trig values for all these. That's a nice big sign there with two eyes. I'll just leave it there. It's kind of cool. So when you fill this in, you get these values. You know that sine of 45 is root 2 over 2. Cosine is root 3 over 2. Sine of 30 is 1/2. And cosine of 45 is root 2 over 2. Hey, once again, notice the setup here for these. We end up with the same answer again. It is totally possible to get the same answer for lots of things that look different. Well, let's try a tangent one. So again, pi over 12 is 15 degrees, so it's 7 times pi over 12. So it's going to be 7 times 15, so it's 105 degrees. It's easier to see the sum this way. So this is equal to the tangent of 60 plus 45 degrees. So we're going to use the rule above, which talks about tangent of A plus B. You can use the definition above, and if you do, you end up with this statement right here. So again, it is challenging to remember these identities, but plugging in the trig values should be pretty straightforward if you remember all of your trig values. So now, what is tangent of 60, tangent of 45? You plug those values in, and when you do, it simplifies to this. You can play around with it a little bit, but that's what it simplifies to. Exciting. The key thing to realize is tangent of 45 is 1. So tangent of 60 is root 3. That's where this comes from right there. So the other thing you can do is you can go backwards. What if you were given something that is the other side of the sum of two angles? What is it actually telling you the sine or cosine of? This right here you should be able to, if you look at all the definitions above, this is the same thing as the sine of 22 plus 13. You have to be careful looking at the positive or negative on the inside there. So this is equal to the sine of 35 degrees. So this statement is the same thing as the sine of 35 degrees right there. You got to put the little angle. And now here, what is this one right here? It's going to be pi over 7 and pi over 5. So it's going to be the sum of pi over 7 plus pi over 5, like this. And then you have to match it to which identity? In this case, you have cosine, cosine minus sine, sine. That is going to be cosine of those two things right there, cosine of those two things. And if you wanted to add the fractions together to turn it into one thing, this would be 5 pi over 35 plus 7 pi over 35. I got a common denominator. So this would be cosine of 12 pi over 35. So this is using the right-hand side of the sum of two angles inside cosine to get this. So here, similarly, it's going to be, again, 75 and 30 degrees on the inside. And then you just have to match the identity. You've got plus, and it's cosine, cosine plus sine, sine. That should be noticeable as the cosine of the sum. So that's going to be the cosine of 105 degrees. And that actually is a value you know. Cosine of 105 degrees is root 2 over 2. So sometimes you can just get the exact answer. So we can also verify identities using what we now know. So remember, we verify identities by turning the one side into the other. So we're going to do the left side into the right. So this is, we're going to use sine A plus B on this side right here. And when you do, you end up with that if you use the definition of sine of A plus B. Now the key thing to realize is cosine of pi is -1, so you end up with sine of x quantity times -1, and then you have cosine of x and sine of pi. Sine of pi is 0. So this equals, this goes away, left with negative sine of x, which is indeed what you want to end up with, or what you were targeting. So let's do the other one. So this is where we're using cosine of A plus B. So what that's going to be written out as is, using the cosine of A plus B, you end up with this. And now you need to remember the trig values. This right here is 0. And then this right here is -1. So you end up with cosine of x times 0 minus sine of x times -1. So this right here goes to 0, and you have two negative signs here, so you end up with sine of x, which is exactly what we wanted. So it takes practice. You'll have reference sheets, especially at the beginning. It just takes practice.